In this lesson, we're going to examine the last idea in trigonometry, the situation where we have non-right triangles, but we don't have a pair of side and angle. There's two situations where the sine law, the idea of the pair of side and angle, can't be used. So situation number one, you know all three sides. Well, obviously, if you know all three sides, you don't have any of the angles, so you don't have a pair. And the second situation is two sides in a contained angle. And by contained, I mean an angle between two known sides. Again, I don't have a pair because I don't know this side, and I don't know that angle or that angle. So these two situations, I need a new tool. And our new tool is called the cosine law. And just to point out, there is no tan law. Okay, so we'll have SOHCAHTOA, sine law, and cosine law. So based on our idea from yesterday, the big letters for angles corresponding opposite sides are small letters. We can create a new law. The law looks like this. This is our cosine law. And when we use the cosine law, the letters that really matter are the letters A. Small a is our unknown side, big A is our unknown angle, and they're across from each other in the formula, and they must be across from each other in the diagram, which we already know about. The trick is here, you need to know one of the two and be trying to find the other one. B and C are interchangeable, and you can call their two sides B or C, it doesn't really make a difference. The good news is there's only two different kinds of questions we can solve, an unknown side or an unknown angle. So we'll take a look at the first example. In this diagram, I do not know a pair. I know 30 is across from X, but I don't know both values. So this is a cosine law question. Because I'm trying to find small x, I'm going to label that with a small a. The corresponding opposite side is the big A. B and C are interchangeable. And so my formula says a squared equals b squared plus c squared minus 2 times b times cos of a. So when I fill it in with my diagram, I have x squared for a, b is 25, and so is c because this is a isosceles triangle. And then I got b again, c again, and the cos of the angle that I have is 30. The nice thing about using this formula is that x is already isolated. It's all on one side. So I can put all of this into my calculator at one time. And if I do that, you should get an answer like 167.4682 and so on. But that's x squared. I don't want x squared, I want x. So to get x, I need to square root that number. And if you do that, x should come out to 12.94. Or for our purposes, 3 sig figs, you can go 12.9. Okay, and that's our first situation of the cosine law, an unknown side of a triangle, a non-right triangle. The second situation involves finding the unknown angle. So again, the key here is I need to label where the A's go. A's have to be the things I don't know. So big A has to be the unknown angle, and small a, the unknown side. B and C are interchangeable, so I'll call this one B and C, though you could do the other order. Now when I go to do this question, again using our formula, so a squared equals b squared plus c squared minus 2bc cos a. And I start filling things in. So I got 65 squared, 72 squared, plus 80 squared minus 2 times 72, 80, and the cos of the angle. You'll notice that the angle is not isolated. The x is all mixed together with all the other numbers. So to solve this, I actually have to rearrange. Now, there's nothing wrong with rearranging, but that means that every time I want to solve an angle, I've got to go through this process of rearranging. But rather than doing that, let's rearrange the equation so that if I have an unknown angle I want to find, I can use it by using a slightly different version of that formula. Okay, so I'm going to get rid of the math that I've been doing, get rid of this piece, and take the formula and rearrange it. So just to point out to you guys, what's happened here is I've brought the b squared over and the c squared over. That leaves me with negative 2bc cos a. I'm trying to get this by itself, so I need to divide out that. So a squared minus b squared minus c squared, all divided by negative 2 BC. It's cosine, which is not quite what the formula looks like because you notice there's a whole bunch of negatives. So what we do in this formula is we divide out all the negatives. If we divide everything by a negative, we end up with negative a squared, positive b squared, positive c squared, and positive 2bc. Or if you will, take this and put it at the end, the formula I have up here. Okay. So this is the formula we're going to be using. That's our formula for the unknown angle using the cosine law. I don't expect you to memorize it, though you're welcome to, but I do need you to know how to use it. So back to the question now. So we're going to take this same question, but we're using our slightly different version of the formula. So cos of the angle equals b squared plus c squared minus a squared. Notice again that we've now put the a's at the ends of the formula. It helps you remember where the a's go. Over 2 times b times c. So in this case, because I'm trying to find an angle, I need to make a ratio. A ratio is a fraction. So what I'm going to do here is I'm going to figure out the top and the bottom of this fraction independently. I'm going to put all the numbers in the top into my calculator and see what we get. And I get 72 squared plus 80 squared. 7,359 on the top. And on the bottom, 11,520. There's my ratio. I want to find the angle, so I'm going to take the inverse of this ratio. I'm going to put it with brackets into my calculator just the way it looks, make it easy for myself. And if you do that right, you should end up with 50.3 degrees to 3 sig figs. Okay, so we have our two different versions. An unknown side, we're going to use the nice version of the formula if we will, where it's already isolated. And an unknown angle, we're going to have to take the rearranged formula and use that. Let's try some examples. So a drive belt wraps around a pulley, three pulleys as shown. Find the length of the belt. So I already know one section of the belt and a second section. All I already need is the third section. This is a cosine law question because here's big A and here's little a, and I know B and C. In particular, it's the first type of cosine law question where I have a known angle. So in my case, x squared equals 14.5 squared plus 16 squared minus 2 times 14.5, 16, and the cos of the angle between them is 35. I can all go to my calculator at once because it's 86.16, but again, that's x squared, so I need to square root it, and I end up with 9.28. That's not the answer to my question. The question was, how long is the pulley? Well, the pulley is made up of the 14.5 for the one side, the 16 for the other, and our new one, 9.28 for the third side. So altogether, that pulley should be 39.78. And this is in centimeters. Okay, so a quick one there. Let's try another one. Cheryl, trying to hit her golf ball between two trees. She estimates the distance as shown. Within what angle must Cheryl make her shot in order to pass between the trees? So Cheryl's down here, and she's got to hit it between this line and this line. In other words, this angle. Well, that angle is across from this side. So that's little a, and that's big A. B and C are interchangeable. So we're using our slightly rearranged version. Cos of A equals b squared plus c squared minus a squared. A is at the end, over 2bc. In my case, it's going to be the cos of x equals b squared plus c squared minus a squared over 2bc. And yes, I know this is an isosceles triangle again. Don't assume they're always isosceles. It just happened to work out that way for these two questions. Okay. So to find our angle, we need to make a ratio. So we got to figure out the top number and the bottom number separately. So on the top we get 2050. On the bottom we can get 2450. That's cos x. I want to get x, the angle, so I need to take an inverse, the inverse of whatever this number happens to work out to. And I'll let my calculator figure out that number. And I got 33.2 degrees. And so that's a word probably should put it there for it. Cheryl has an angle of 33.2 degrees within which she must hit the ball. Okay. Okay, last one. We got Sally. She's making stained glass windows. Each piece of glass is surrounded by lead edging. Sally claims that she can create an acute triangle in part of a window using pieces of lead that are 15, 36, and 60. Is she correct? Justify your decision. So, an acute triangle, what does that mean to us? That means all the angles have to be less than 90. Okay, so if I were to draw a triangle, right, those are all less than 90, obviously. She's saying she can create one that's 15, 36, and 60. And obviously, this is not to scale. I want to know if she's correct or not. In other words, I want to know what are the angles of that triangle. In particular, what's the angle, the biggest angle of that triangle? Because if it's less than 90, the other two have to be less than 90 too. Okay? If the biggest angle happens to be obtuse, well, then she's wrong. But if the biggest angle is acute, then she's right. So I gotta find the biggest angle. The question we have to ask ourselves is, where's the biggest angle? The good news is it's always across from the biggest side. So it needs to be up here. That's the angle I need to find. So that's A and A. I got B and C. So we're using that rearranged version again. So in this case, I'm going to have the cos of A equals B squared plus C squared minus A squared over 2BC. And we're going to create that ratio idea again. So on the top, we should get negative 2079. It's okay to have negative, nothing wrong with that. On the bottom, we get 1080 cos A. Okay, we want to take the inverse of this, right? That's how we find angles. So if I put that in my calculator, and you try it, you're going to end up with an error. It can't be done. Which means that she can't form a triangle. She's wrong. But we have to ask ourselves, why can't it be done? So we need to go back to the idea of SOHCAHTOA for a second, if you will. Because even though we're using the cosine law here, cos really refers to this ratio of an adjacent and a hypotenuse. An adjacent and a hypotenuse. So I need to ask you a question. Is it possible for an adjacent side to be bigger than a hypotenuse? Isn't our definition of a hypotenuse that it's the longest side of a triangle? So the fact that the hypotenuse is shorter than adjacent tells me that's not possible. And she's wrong. It can't possibly be true because our hypotenuse has to be the longest side. So if you come across a situation where your hypotenuse is shorter than one of the other sides, you know you've created an impossible triangle. Okay, that's the end of that lesson. Here's our homework. Give it a try. Space those numbers out there. There's just a couple of questions today, just to make sure we can practice cosine law, the two different versions, finding sines, finding angles. If you're stuck, come see me. We'll figure some stuff out.